This is Algebra 2A, Lesson 3.2, Basic Function Families. So we're going to look at 4 function families, their equations, and what their graphs would look like. We're going to start with the linear function. Linear function we're usually all pretty familiar with. We remember y equals mx plus b. The parent function then is just y equals x. M would be a dilation on that. B would be a translation on that, and we're going to get more into function transformations in the next couple lessons. But the parent function for the linear is y equals x. And if we were going to look at a graph of that, it is a line. Now I want to talk about the domain and the range of the parent function. The domain of the parent function is all real numbers. It goes all the way to the left, all the way to the right, forever and ever and ever. So we can represent that with a negative infinity less than or equal to x less than or equal to infinity. There is a shortcut, and that is just all real numbers. The range of the parent function is the same. It goes forever down and forever up. So we can say, again, negative infinity less than or equal to y less than or equal to infinity, but we can also just say all real numbers. The next family I want to talk about is quadratics. Now, depending on how much algebra you've taken, that may or may not be familiar to you, but quadratic parent function is y equals x raised to the power of 2. The shape of that graph then is a U-shaped graph, and that is called a parabola. Because when we multiply something by itself, it turns positive, we only have positive output values here. But the input values is still all real numbers. So we'll say the domain of our parent function is, again, negative infinity to positive infinity. Or we can shortcut that with all real numbers. The range of our parent function, like I said, is only positive values. So it's going to be only from 0 up to our positive infinity values. And a shortcut way to write that would be y greater than or equal to 0. So either of those would be fine for the range of our parent function. The next family I want to talk about is the square root function. So square and square roots, quadratics and square roots, they are inverses of each other. And if we're going to look at the shape of that graph, when we square root a number, we can only square root positive numbers. And when we square root a positive, we will end up with a positive value as well. So we're only going to be looking at one quadrant here. That is our square root graph. And it is like a parabola, but turned on its side. But because we can't root negatives and we don't get outputs that are negatives, we only have the positive values. So for the domain then, because we can only root positive values, our domain is only positive numbers. And for our range, because our outputs are only positive values, our range is also only positive values. So we can shortcut these y and x respectively greater than or equal to 0. But either way. And the fourth function I want to talk about is the absolute value function. Again, this is a function that you may or may not be too familiar with from history in other algebra classes. And we're looking at y equals a vertical bar and another vertical bar. Okay? And one way to think about it is make it positive. But mathematically speaking, we are talking about the distance from 0. And because distance is always positive, if we say how far is 5 from 0, 5 is 5 from 0. How far is -5 from 0? -5 is also 5 units from 0. We basically just take our number n, make it positive. And as such, again, we don't have any negative output values. All of our positive numbers output positive, but all of our negative input values also output positive. So our graph ends up looking like a V. For the domain, you can input any value. Oops, that's an infinity. And for the range, you will only be outputting positive values. So that is all numbers on the domain, but only positive numbers on the range. Lots of information there. Let's try a couple of examples. Example A says, identify the type of function, then give the domain and range. So just by looking at the shape of the graph, I see a V-shaped graph. He has been transformed. It's been reflected. It's been translated, but that is still a V-shaped graph. So this is an absolute value function. Absolute value. The domain of this function is all real numbers. It goes forever to the left, forever to the right. But because my graph has been transformed, my range maxes out here and then only goes down from there. So I'm going to go 1, 2, 3, 4. I think that looks like 5. So we're going to say negative infinity less than or equal to y less than or equal to positive 5. You could also say y less than or equal to positive 5. Letter B, I see a U-shaped graph. I know that that is a quadratic. If I'm looking for the domain on quadratics is all real numbers. The range on this transformed quadratic, it looks like it's only the values greater than -2. So I'm going to say y greater than or equal to -2. You could say -2 through infinity, but I'm going to go with a little shorter way to represent that. Letter C, I see a line. Lines belong to the linear family, and the domain and range for all lines is both all real numbers. Now I have 3 functions that are given in equation form instead of picture form, but using the equations I can deduce what that is. So like this first one here, I see an x, I don't see any powers, I don't see any special symbols, no bars, no roots. That's a linear function. And if we remember back, I said mx plus b. This is exactly mx plus b form. We have our slope of -3. We have our intercept of +2. That is a linear function. And I know that the domain and range for all linear functions is all real numbers. For letter E, my special symbol is vertical bars. Vertical bars give me an absolute value function. I'm going to shortcut that. Abs value. We haven't really talked about the transformations yet, but I'm going to give you the domain is all real numbers for all absolute value functions. And then the range is going to be all values greater than 0, positive values. Letter F, we have a square root function. And the domain and range for the parent function is our positive values, but because this one has been translated, I know that the domain is actually going to be numbers greater than or equal to 2. The range will still be all real numbers. And as we get into our different functions, we'll talk more about how to figure out the domain and range. Example B, we have a function 2x squared minus 8. What type of function is this? I see a power of 2. I know when I see a power of 2, that is a trademark of my quadratic functions. Apologies. There we go. Power 2 is a trademark of quadratic functions. Evaluate f of 2. So our function notation, all I have to do is replace the 2 in for the x and then calculate that value. You can use a calculator if you have one. You can use order of operations if you want to use your brain calculator. So I'm going to start with my exponent. 2 squared is 4. I'm going to multiply that by 2. 4 times 2 is 8. I will do my subtraction. 8 take away 8 is 0. And finally solve f of x equal to 24. So again, remembering my function notation, I'm going to take my function, I'm going to set it equal to 24, and then I will use my inverse operations to isolate x. So we're going to add 8 to each side. Drop down the 2x squared, 8 and negative 8 is 0, so they're gone. 24 plus 8 is 32. Now I'm going to undo this multiplication, so I will divide both sides by 2. And x squared remains. 2 divided by 2 is 1. I don't need to write the invisible 1. 32 over 2 is 16. And then the final step. So we are usually pretty good with plus undoes, minus, and divide undoes time. The opposite of a square, and I did say it earlier, is square root. So I will square root both sides. And that tells me that x is 4. Now, technically, it's also negative 4, but I don't think we're going to talk about that for a couple lessons. So if you have 4, I'll take it. If you also have negative 4, that's even better. But that is it for the notes on this lesson. Good luck on the exercises, and let me know if you have any questions.